Okay, so on average, 2% of a particular model of laptop are faulty. Faults occur independently and randomly. Find the probability that exactly 1 in a batch of 10 laptops is faulty. So we've got to think, what distribution have we been given here? And this is a binomial distribution. N is 10 and P is 0.02. So the probability that X is equal to 1 is 10, choose 1, 0.02 to the power 1, 0.98 to the power 9. And when you type that into your calculator, you get 0.1667. You can, of course, use binomial PD to work this out on the calculator as well. If you go to distributions, binomial PD, we just want X is 1, N was 10, probability was 0.02, and we get 0.1667 there on the calculator as well. Okay. A large company buys a batch of 2,000 of these laptops. State the exact distribution. State means there's no working out. So we are just being told to write this. Right, that's all it's asking for. What distribution is this? And you've just, if you remember, you've just used binomial in part 1. So it's the same, but with a larger sample. But the reason you are asked to do that is in the next part of the question. Use a suitable approximating distribution. Okay, so the reason we need to do this, when n is 2,000, your calculator is not going to handle binomial. Okay, so you can't use binomial anymore. N is too large, so they're telling you to approximate it. The only approximating distribution you will do is the normal approximation of the binomial. So you know that if X is BNP, then you can model it. It's approximately normal the mean, mu, is NP, and the variance is NPQ. So we just need to work those two things out. So we've got B 2000 0.2. So NP is 2000 times 0.2. No, 0.02, isn't it? So 2000 times 0.02 is 40. Is that right? Yeah. And NPQ is 2000 times 0.02 times Q, which is 0.98. Okay, I can't do that in my head, but I have got it on the answer sheet. That works out to be 39.2. So we've now got X to be normal, 40, 39.2 as my sigma squared. Remember, when you're using that in the calculator, we always type sigma in. So when we type that in, we're going to use root 39.2. Yes. So Q is, so if P is the probability of success, Q is the probability of failure. Sorry. If that's the probability of success, Q is just 1 minus P. It's the probability of failure. Okay. So you could also write this as NP 1 minus P, which is another way you might see it written. And my sigma is going to be root 39.2, because remember, this is sigma squared. It's the variance, and my calculator asks for standard deviation. Okay. So, other thing to remember, when we do the approximation of normal distribution, binomial distribution is discrete data, but I have got, my normal distribution must use continuous data. So I want at most 50. So I want the probability that X is less than 50, which means I need to do the probability that X is less than 50.5. I've got to do that continuity correction again. And then I can just go to the calculator normal. My lower limit, upper limit is 50.5. Sigma is root 39.2 and mu is 40. And I get 0.9532. Okay.